points, lines, and planes. You can probably quickly see points, lines, and planes in the world around us. However, it's the naming of points, lines, and planes with mathematical symbols that we really need to pay attention to, because that's the only part of this that will give you any trouble. Alright? So make sure you put on your thinking caps for this. Before I continue forward, I do want to remind you that I passed out a collaboration rubric yesterday. What am I looking for in terms of this collaboration rubric? How are you going to get scored? Okay? What does that look like?
Staying awake.
Definitely got to stay awake. Taking notes during whole class discussion, right? Is it just enough to take notes? Nope, you got to also what? Well, even during the whole class discussion, you need to be taking notes, but you also need to be actively participating by offering ideas, asking questions, being engaged in the whole class discussion. Within your small group, you need to be what? Communicating about what? Math. Is it good to communicate about the football game tonight during this math class?
Yes.
No. Okay, yes sir. Huh? At 2? So, it is not a good idea it's not a good idea to be communicating about things other than math, because I am looking for you to be consistently talking about the math within your groups. Is it enough to just talk though? Do we need to look back at this rubric for just a second before we start with today so that you know what you're supposed to be doing?
No.
Okay, because y'all aren't answering the questions.
What do you say?
Beyond just talking, what do you need to do within your group?
Listen to other ideas.
Thank you. Don't just talk. Listen to each other's ideas. And ask each other questions. If you're going to help each other grow and learn and push each other to be able to do more and be more, you got to ask each other questions. Is that clear? Okay. This is a collaborative thing. The reason why I developed this rubric with a friend of mine is, at the end of the day, the people who learn the most are the ones who talk the most about the math. I have done my best to design every group so that every person has the best chance of being successful. I'm not saying it's perfect, but there's 28 of us in here. I have to move the groups around in a certain way. But I actually set up every single group so that the people within that group can learn to the best of their ability, so that you can collaborate and help each other learn. We all clear on this? All right. So the basics of geometry. Let's say group 1. What is something that you would say could go along with the idea of the dot that you were given?
Clock.
The clock kind of has a similar shape. Okay. Group 2.
Magnet.
Say again.
Magnet.
The magnet. Okay. Group 3. By the way, if I'm writing this down, it might be a good thing to, write these down as well. Group 3, did you come up with anything? Did y'all not talk about this?
We did.
Maybe?
That thing on my book,
The thing on what book?
that red book that's on top of the shelf.
Oh, the circle on that's my diploma from UA. So just a circle? A circular thing? Okay? It's typically what we think. Let me ask you all this. What about that corner up there? Do you see the corner in the ceiling? Where the ceiling and the walls meet each other? Is that creating a dot-like thing? Don't think so?
Yes, yeah.
I guess.
Well,
Well, let me ask you a different question. What geometric shape, or what geometric concept, it's not really a shape, what geometric concept do you think we are representing with this dot?
Cylinder.
Think about the 3 words that are the basics of geometry.
Point.
That's a point?
Origin.
I think, yeah, point.
A point? And tell me again, what about the corner up there? Could that be a point in space?
What's in that corner?
A singular, huh?
What's in that corner? What are you talking about?
This corner right here. You see the corner where the walls meet and the ceiling meets?
Yeah, what are you talking about? Point. Section?
Is that a point?
Oh, from the edges?
Yes, well where the walls meet.
I mean, yes.
Is it a point?
Yes.
Yes, okay. So what we want to recognize is what we are talking about here are points. So what do you think we mean when we talk about a point in geometry?
What you learned in your section? I'm in the
It could be.
Where two lines meet.
Triangles.
So two lines intersect where, okay, so I will say this, there is a point where two lines intersect, but that is not what we mean by a point. Say again?
Where two lines meet.
You talking about
Hey, so I want to point this out though, I guess kind of,
don't that dot with the line turns or something?
say that one more time.
Don't that point with the line turns at certain degrees?
Point where the line turns certain degrees.
I'm going off memory here.
Off memory,
Yeah.
okay? So, is this a point?
Yeah.
Yes? Are there any lines intersecting there?
Nah.
No?
But they could be.
There could be, but I mean, there's nothing there right now, right? Alright. I mean, is there, I know, look at my fingertip, this is weird, but is there a point right here at the edge of my fingertip? There's nothing there, but is there a point?
Yeah.
Yes? Yes?
Yeah, because you're pointing.
I'm pointing, so there is a point there, correct? Yes?
No way.
No one's dressed up and I'm teaching right now. Thank you though. I didn't see anybody right here dressed up for it. I guess you literally are, but my okay. My point is this though, okay? Is there actually anything at the end of my finger?
No.
No, but there is still a point in space right there. There is space there, right? So when we are talking about a point, and this is the definition you want to write down, it is literally just a location. Without any dimensions. Points are always around us. Any location that you go to on a map, that's at a point. Anywhere that you have two lines meeting, there's a point. Anywhere just in space, that's a point. It's just a location. That's all a point is. Does that make sense? We good with that idea?
Yeah.
Ready to move forward from a point?
You got a question.
I don't have an answer. What's your question?
What are you going to do with the product?
I want to eat them, all of them myself. It's for my Algebra 2 students and another teacher's going to use them. Okay. What do you mean, oh wow? You'll get chances to do stuff like that too.
Unless you're very sure.
Okay, so the next one is line. I think I stopped with group 3, right? Group 4, the little straw that y'all got. Where did you see the straw-like shape around this room? Or straw-like object idea?
The American flags.
Okay, so this stick, that's the American flag? We agree with that?
Yeah.
Yes.
Why do you say no, Kelsey?
I just like, yeah.
Kelsey just always being a jokester. Okay, so the American flag stick. Alright, group 5,
Here comes.
a pencil. Does a pencil have a similar idea as a straw? And group 6. Huh? The rod? Okay. So I see a theme for everyone, okay? Let me ask you this question then. Could this be similar to the straw?
Yes.
Yeah.
How so?
There's a line.
Because it's a
Line.
line. No, it's like, I bring this up because everything y'all picked was round, right? It was a cylindrical shape. But what are we talking about when we talk about a straw? We're talking about a line, okay? So what we're talking about here is a line. So what do we mean by a line?
Length.
According to plan.
Okay, something to do with length, something to do with the coordinate plane. Say again. Okay, so I want to point this out. I hear someone saying a length. Is there any kind of width with it?
Yeah. The up and
Like, when you look at this, y'all are saying this is a line. It's got length, doesn't it?
and they got ends.
Does it have any kind of width?
Not really.
No, not really.
Not really. Remember, and I do want to point this out. I have to draw a point like this, right? But it says it doesn't have any dimensions. So is a point really that big? No, a point actually doesn't technically exist. We represent it with that because we can't make something that small. It's important to recognize a line is a similar idea. So let me point this out. Okay? We good with that being a point?
Yes.
Yeah? What about that?
Yes.
And then if I put a point right there, what do I have through all those points?
A line.
Okay? And so, do I solve a line?
Yes.
What about now?
Yes.
Now?
Yes.
I'm not gonna keep.
What happens when I put a whole bunch of points on top of each other?
Line.
It's becoming a line. So what is a line?
Lots of small points.
It's not just lots of small points. Any guesses how many points it actually is?
Infinite.
There we go. A line is infinitely many points. Okay? Let me make sure I get this completely right. Infinitely many points connected in a straight path that continues forever. So there's no width.
I've heard that.
Pretty sure you heard me say that a couple of years ago.
Yeah.
Yep. It's a weird thing where like geometry and algebra are connected somehow. Okay. Now I want to point this out. Is this continuing forever?
No.
No. This is just a representation. Does anything in this world continue forever?
Yes.
What?
I like them.
I mean, time continues, but do we know it's going to go forever?
No.
Nope. Did time start somewhere?
Yep.
Probably not.
So,
I don't know.
so there's
Numbers.
The same size.
Okay.
1 to infinity.
numbers do continue forever, but those are representations of things like physical objects around us. Does anything continue forever?
The room.
No, not
What did you say?
The room.
The road?
No.
Wait,
Oh.
Anyone know any road that continues forever?
No.
Okay? There's a dead end somewhere. So here's what I want you to understand. This concept is kind of tough to understand it sometimes that it continues forever because we cannot actually create anything. We just have to represent it. So technically, this is not a line. What would I need to put here in order to indicate that it's a line?
Arrows.
Arrows on either end indicates that it's continuing forever, right? So please understand, like, it is tough to fully understand points and to fully understand lines because all we can do is represent them. We can't actually ever see them in their entirety. Does that make sense? We good with that idea? Okay, group 7. Hit us up with something for the note card. What is something around this room that we thought models the note card?
The piece.
The paper, so the, I don't know what to call it, laminated, laminated, we'll just say signs, because that sign covers that thing as well. So laminated signs, anything else?
Door.
The door? Anything else?
Maybe the window around the door?
The windows? How about the walls?
Yeah.
What about the ceiling? Okay? Anyone have a guess what we call that geometric concept that is flat like that? Gotta go. Say it again. It's a plane, right? We have points, we have lines, we have planes. Okay? So if a point is a specific location without any dimensions, a line is infinitely many points connected in a straight path that continues forever. What do we mean by a plane?
I don't know.
You got, okay.
Like the surface? No.
So the surface of something is a plane. Okay, so a flat, but here's the thing, we don't want to say it's a surface because it's not always a surface. Technically, you can't see it right now, but between my fingers is a plane. And it's continuous.
Between.
Pointed line. It's a combination.
But it's not a line, it's
But
It's
the
a
space.
combination
I don't know.
of
It's,
points.
I know it's something.
okay. So we're starting to get in there. So it is a flat I don't like this language that I'm getting this from. I'm going to put quotation marks around it. But it's a flat surface, because that's the best word we have for it, but it's not really. So it's a flat surface that has no thickness. That has no thickness. And continues forever. Anyone want to guess how many directions?
All directions.
All directions would mean it goes this way and that way and that way. So, and how many directions then?
Two.
Right? When you say horizontally, even though you have that way and that way, that's just one direction. Okay? Notice how it was 0 dimensions or 0 directions for a point. How many directions for a line? One. How many directions for a plane? Two. It depends. So so here's what I want you to be careful about. So it's not, I'll wait till everyone finishes writing this. Okay. So, piece of paper that's kind of like a plane, right? Just pretend like it's continuing forever in each direction, right? So I don't want you to just think that it's left, right, up, and down, because there's a plane right here as well, right? There's also a plane in this direction, and then there's planes in this direction. You see how I can change the direction of that plane infinitely many ways? And so you can't just think that it's up, right, left, down. It's just, it goes in two directions, and just a slight angle creates a new plane. Does that make sense? Sure?
No.
Okay, can we all agree? There's a plane right here?
Yeah.
Yeah? If I change it like this, is that the same plane?
No.
That's a completely new plane, correct?
Yeah.
What about if I change it here?
Different.
That's a different plane, isn't it? What about if I move it to here? Is that a new plane?
Yes.
So how many planes are there?
Infinitely.
There's infinitely many. And do you see, right, it's not just up, down, left, right, it's lots of different directions. It's just it has two directions, right? It's only going this way, this way, this way, and this way. But then when I move it to here, it's going that way, that way, that way, and this way. So it's got two directions every time, but there's lots of orientations for it. Does that make sense?
Yes.
Okay. Does anyone want to ask any other questions before I continue? Because I know that's a little higher level thinking. I just wanted to address that question from Jalen, not Jade. We good?
Yeah.
Okay. So, from there, I want us to think about it. I've already heard a lot of these ideas already come up within our conversations. Through any 2 points, what will there always be?
Origin.
Line.
If I have 2 points, what can I draw through them?
A line.
A line. So through any 2 points, there is a line. That's something important to notice. If technically, how many points are there on a line? Infinitely many, right? But how many points do I need to define a line? Two. So 2 points, I can draw the line, but then there's infinitely many points on that line. Right? It's a key distinction and an important idea. If 2 lines intersect, someone was talking about this earlier, I believe it was Matthew. If 2 lines intersect, what do we have? Then there's a point. So if 2 lines intersect, then there is a point. Now this is something we may not have thought about before. But what if 2 planes intersect?
No.
2 planes intersect. Look around the room to see if you can see any place where 2 planes might be intersecting and we get something. So we get the ceiling intersecting with what?
The lines are
Those are lines intersecting, huh?
The wall.
Okay, when the ceiling intersects with the wall, what shape do we see along there?
a line.
I heard some people saying, what? A line. Look at the edge where the 2 planes are intersecting. What's along there? A line, right, is extending along there. So if two planes intersect, then there is a line. Oof, this next one's a little tough. Through any three non-collinear points. What in the world do you think we mean by non-collinear?
They're not going straight line?
So they're not in a line. If we say collinear, it's with that line, right? So this part means within a line. So if we say it is non-collinear, we are saying it is not within a line. So, would these 3 points be non-collinear?
No. I mean, yeah. No.
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 Okay, why not? Okay. That's creating a line, right? That's not what I want. I need another point that is non-collinear. So what about now? Would that be non-collinear?
No.
Is that forming one single line? No? So is that non-collinear?
Yes.
Any guesses what we could define with 3 non-collinear points?
That's it.
A triangle.
That does look like a triangle. Think about the geometric concepts that we are studying right now.
A plane.
A plane.
3 points that are non-collinear define a plane.
You just confused me.
Yeah, a lot. Not me. A rhombus.
No, it's just a. We typically use that shape to indicate that it's a plane.
I say, how do dots meet that?
Say again.
I say, how do dots meet that shape?
It doesn't. So please understand. What I'm not saying that those 3 dots create that shape. I am saying that those 3 points can define that plane.
Oh, okay.
Because remember, how many directions does a plane have to have? 2. Now I have one direction here. By introducing this 3rd point, I have a 2nd direction here. That's all I'm saying.
Okay.
So 3 points, non-collinear points, are defining a plane. So through any 3 non-collinear points, there is a plane. And again, notice that's the idea. I'm not saying that those 3 points create a shape. I'm saying that through those points, just like with a line, I have 2 points, and then when I go through those 2 points, I create the line, right? When I go through those 3 points, I create a plane. Because and you also have to remember this, is it really stopping here?
No.
It continues forever. We all good with that idea? Okay. So I need us to pay attention to that idea that it is continuing forever. Through any 3 points that are not on the same line?
That's
That's
the same thing?
Same thing. That's not supposed to say that. Just ignore it. If 2 points lie on a plane, then the line what? 2 points define a what?
Line.
Define a line, right? So if there are 2 points that are on a plane, then the line is where? On the plane. Okay, that's all I'm saying, right? If 2 points lie on a plane, then the line is on the plane.
Wow.
Okay? Before we go to the next little activity, do we have any questions about what we have covered so far? Okay? So, what I am passing out right now is a packet for your entire little group. While you are working with this, or what this is, turn over the front page, or the first page, look at the back. Okay? Did everyone get a copy? Okay? So, if you look, let me actually go to the slide so I can show it. Okay? So what we have here is a model, meaning that it represents A line, a segment, a ray, an angle, a plane, and a point. We have it drawn, we have it named, facts about it, and words or symbols. Everything is somewhere in here. Work together to sort out each of these into the correct little space. Once you have it filled out, write down notes about what goes where. Can you do this all on your own? No. Have we even talked about every single part up here? No. We've talked about the 3 most important parts. This is a chance for you to explore different ideas. I will be asking you questions, but this is also a time for you to engage with your group to help each other grow and to learn. Can you learn today if you're not talking with your group members? No. Okay? Be engaged, help each other out, try to figure out where each of these things go, and then from this, we will learn some of the key things about, hey, how do we name a line? How do we draw a line? How do we model a line? Are we all clear on this?
Yes, sir.
What are your questions before I release you to get started? Okay, here's one recommendation I have for you. I would pick one person's paper and I would stack these or sort these on that person's paper. That way they don't get lost and it's all contained in one single space. And so you can talk and discuss and debate and help each other find where everything goes. Once you have them all sorted, that's when I would start to write notes about those different details. Ready to get started? 3, 2, 1, go.
Can you give me these papers?
I did not give you all one?
No, I meant
I thought she said
It's right there. That's where you're supposed to write notes on. Yeah. Like these literally fit in there. That's that shape, that size.
So you just write this on here and
Onto there. That's what I was saying. You sort it on one of the papers and then write the notes after.
I
Okay.
don't have no.